Hello friends, welcome to the sessions of lectures of Mathematics-02. Up to last session, we have seen the Frobenius method, and in Frobenius method, we have discussed the case 1 and case 2 and how to find the solution for case 1 and case 2. That means whenever the roots are differing by non-integer and whenever the two roots are same. In today's session, we are going to discuss the case 3. In case 3, we have roots are differing by an integer. That means R1 minus R2 or R2 minus R1 is integer. Okay, it is integer and sum of the coefficient becomes indeterminate for the smaller root. That means the smaller value is R1 and for that if one of the coefficient becomes indeterminate, then you have to put only the smaller root in y and that will give you directly the general solution which contains two arbitrary constant. Okay. Now we are going to check this thing in an example. Find the series solution of xy double dash plus y dash plus xy is equal to 0 by Frobenius method. Now again the same thing we have to repeat. If you are starting with a solution, then first write down your equation in a standard form. So y double dash plus 1 upon x y dash plus y is equal to 0, and that implies px is equal to 1 upon x and qx is 1. Now px is not analytic at 0. Px is not analytic at x is equal to 0. Now see, here it is not given the point, but you have given that by Frobenius method. By Frobenius method, that means you have to find the solution near regular singular point. So x equal to 0 is now your singular point. This is the only singular point. So you have to check out limit x tends to 0 x into px, and that is nothing but limit x tends to 0 x into 1 upon x, so it has a value 1, and limit x tends to 0 x square into qx, so it is nothing but limit x tends to 0 x square into 1, and that will has a value 0 because 0 into anything will have a value 0. So both values are finite, so and therefore x is equal to 0 is a regular singular point. Now this is a regular singular point, so we are starting with our standard assumptions. So let or assume y is equal to x raised to r into sigma m running from 0 to infinity am x raised to m, where a0 is not equal to 0. This is equation number 2. B, a trial solution of equation 1. Now first of all, this is our equation 1. Okay. So y is going to be sigma m running from 0 to infinity am x raised to m plus r, and that will give you y dash is equal to sigma m running from 0 to infinity m plus r am x raised to m plus r minus 1, and y double dash, that will be a m running from 0 to infinity m plus r m plus r minus 1 am x raised to m plus r minus 2. Correct? These are the standard things. Now putting these values in equation 1. y, y dash and y double dash in equation 1. So your equation is x y double dash plus y dash plus xy is equal to 0, and that means you have x into sigma m running from 0 to infinity m plus r minus 1 am x raised to m plus r minus 2 plus y dash is nothing but m running from 0 to infinity m plus r am x raised to m plus r minus 1 plus x into y, that is nothing but m running from 0 to infinity am x raised to m plus r is equal to 0. Now see, if you are multiplying this x inside, then you will have sigma m running from 0 to infinity m plus r minus 1 am x raised to m plus r minus 1 plus sigma m running from 0 to infinity m plus r am x raised to m plus r minus 1 plus multiplying this x inside, that will give m running from 0 to infinity am x raised to m plus r plus 1 is equal to 0. Now what we are going to do, from these two we are going to common out the terms because this both has the same power. So m plus r am x raised to common out, correct? Okay, sorry, here we have to take an example as a 2 upon, because otherwise it is a case of repeating. So we are starting with a 2 upon. So this will be a 2 upon and this will be a 2. Okay. And this will be a 2. Done. Now here the only change is, here you have term 2 into. So here you have value 2. Now we are going to simplify this term. Then what you will have, sigma m running from 0 to infinity m plus r minus 1 plus 2 into m plus r x raised to m plus r minus 1, correct? And the second term is plus sigma m running from 0 to infinity am x raised to m plus r plus 1 is equal to 0. Now see, this degree is m plus r minus 1. This degree is m plus r plus 1. So here you have to reduce your degree to the lowest degree form. So m will be replaced with m minus 2. So the first term is going to be a 0 to infinity m plus r plus 1 into m plus r am x raised to m plus r minus 1, and plus this term is going to be a m is running from 2 to infinity a of m minus 2 x raised to m plus r minus 1. Now separate the terms with 0 and 1. So if you are going to put 0, then it will be a r plus 1 into r a0 x raised to a0 x raised to r minus 1 plus, if you are going to put m is equal to 1, then you will have r plus 2 r plus 1 a1 x raised to r x raised to r, okay, plus sigma m is running from 2 to infinity. Now this two terms are going to be common out. So m plus r plus 1, m plus r am plus a of m minus 2 x raised to m plus r minus 1. Now equate coefficients with 0, that will give you first coefficient is x raised to r minus 1, and that is nothing but r plus 1 r a0 x, that is equal to 0, and that will give you r is equal to minus 1 and 0. So the smaller root is r1, larger root is r2, and if you are finding the r2 minus r1, then it will be a 0 minus minus plus 1. This is integer, and since it is integer, so you have to apply the case of integer. Now then you are going to compare the coefficient of x raised to r. X raised to r is r plus 2, r plus 1, a1 is equal to 0. Now see, here if you are going to put r1 is equal to minus 1, that means r is equal to minus 1, then you will have 0 is equal to 0. That means you cannot find the value of a1, correct? And since a1 is, you cannot find the value of a1, so a1 is going to be an indeterminate, and here a1 becomes indeterminate for r is equal to minus 1, correct? So this is the case 3, differing by integer and one of the coefficient becomes indeterminate. Indeterminate, that means you cannot find the value of a1, correct? Now these two terms have completed. Now we are going on to the general term. So the general term x raised to m plus r minus 1, that is m plus r plus 1, m plus r am plus a of m minus 2 is equal to 0, and we are going to make the larger one subject. So minus of am minus 2 divided by m plus r plus 1 and m plus r. Okay. Now you have to put m is equal to 2 because index is starting with 2. So a2 will be minus a0 upon r plus 3, r plus 2. Same manner m is equal to 3, then a3 is minus a1 upon r plus 4, r plus 3. Same manner m is equal to 4, so a4 is minus a2 upon r plus 5, r plus 4. But a2 is nothing but a0 upon, so if you are going to put, then it is a0 upon r plus 5, r plus 4, r plus 3, r plus 2. Same manner for m is equal to 5, you will get a5 is minus a3 divided by r plus 6, r plus 5, and that will be a a1 divided by r plus 6, r plus 5, r plus 4 and r plus 3. Now these are the enough terms. We are going to put these values in a series. So putting values of am in equation 2. So y is equal to x raised to m into a0 plus a1x plus a2x square and so on. So that will give you y is equal to x raised to r into a0 plus a1x. See, you cannot find, a1 is indeterminate, so we have to put a1 as it is. a2 is equal to minus a0 upon r plus 3 r plus 2, r plus 3 r plus 2 into x square minus a3 as a value a1 upon r plus 4 r plus 3 into x cube plus a0 upon r plus 5 r plus 4 r plus 3 r plus 2 x raised to 4 and a1 upon r plus 6 r plus 5 r plus 4 and r plus 3 into x raised to 5 plus dot dot dot. Now, since one of the coefficient become indeterminate, so you only have to put r is equal to minus 1, which is a smaller root, and that will give you the general solution, correct? And therefore, the general solution is y is equal to x raised to minus 1 a0 plus a1x minus a0 upon minus 1 plus 3, that is 2 into 1 x square. Same manner here, a1 upon 3 into 2x cube. Same manner here, a0 upon 4 into 3 into 2 into 1 x raised to 4 plus a1 upon 5 into 4 into 3 into 2 x raised to 5 and so on. So if you are writing in a simple form, say by separating the coefficient with a0 and a1, then you will have 1 minus x square by 2 factorial plus x raised to 4 by 4 factorial and so on, plus a1 into x inverse x minus x cube by 3 factorial plus x raised to 5 by 5 factorial and so on. And if you are aware of these are the series of sine and cos, then you can write this as x inverse into cos x plus a0 x inverse into sine x. Otherwise, put this in a as it is form. Okay. So these are the topics which we have covered for the roots differing by integer and one of the coefficient become indeterminate. So if you have any doubt and any query in this topic, then please feel free to contact me. Thank you so much for watching me.